All right, so this will be the last slide for today so that we can digest and assimilate everything I've taught so far. So I've explained alkenes, alkanes, alkenes, and alkynes. All right, now let's see comparison between the number one. You see that general formula: alkanes, you have CnH2n plus 2. Alkenes, you have CnH2n. Alkynes, you have CnH2n minus 2. In case you can't see what's on the slide, CnH2n minus 2 for alkyne. All right, then their nature, I've explained in the last two slides. Alkanes are saturated compounds. Alkenes and alkynes are unsaturated organic compounds. Now, the reactions. This is one part you have to take very seriously. In short, you have to write this down and asterisk it because it's one question that Jamb asks every time. They ask this question every time. They can ask, okay, for example, which of the following reactions is common to alkane? Right, so alkanes, the general reactions common to them is substitution reactions. Substitution reactions. Alkenes have addition reactions and polymerization reactions. All right, while alkynes also have addition reaction and polymerization reactions. We're going to look at all that, but I think you should do that in your SS2 or SS1 when you did type of chemical reactions, where you have displacement reactions, redox reactions, different kind of reactions. The one is SS1 work. If you have time, you can touch a little bit on that type of chemical reactions, but in focus, we're looking at reactions involved. Now, before I touch these reactions, substitution reactions for alkane, addition and polymerization for alkenes and alkynes, I will first of all take the general reactions. The three of them undergo all hydrocarbons, whether aliphatic, aromatic, cyclic, all hydrocarbons undergo one general chemical reaction that is called combustion reaction. What does it mean? What does combustion reaction mean? Combustion reaction is simply a reaction that involves oxygen. That means you are reacting an hydrocarbon or an organic compound, yes, an hydrocarbon with oxygen. Is another name they use for burning. Combustion reaction, burning, reacting a compound with oxygen. Then for an organic compound of hydrocarbon, the formula is when you react an hydrocarbon, CnXHY, any hydrocarbon plus oxygen, you must definitely have carbon 4 oxide and steam. Carbon 4 oxide and steam. Then you now balance the chemical reaction. So any hydrocarbon you react with oxygen, you must always have carbon dioxide or carbon 4 oxide and steam, H2O and steam. So the next slide I'm going to send after this, it will be a pictorial representation of the reactions so that you see. So I will explain combustion reaction. I'll take an example of an alkane. I'll take an alkene. I'll take an alkyne. Then I'll explain. I will touch a little bit on substitution reactions. Then in our next class, we'll focus more on addition reactions and polymerization reactions. All right. So in the slide I'm going to say now, I'll touch on substitution reactions. Okay, I'll touch on combustion reactions, substitution reactions, and addition reactions. You'll know that in our next class, we'll now dwell more on polymerization reaction because the kind of reaction on its own, in its own class, in its own category. I'm going to look at that. So I'll send the next slide now on the group. So those are basically the comparison between alkanes, alkenes, and alkynes. If you have any question, you drop it on the group, not on my personal wall, on the group now, because chemistry, I think virtually every one of us offer chemistry. All right, so drop the questions, the contributions, the comments, suggestions, how we can be better in terms of transmission. Drop all those stuffs on the group. I also drop the Jamb questions now involving this first part I just treated. Thank you very much for your time. Good evening.